Our topic for today is about the empirical formula. At the end of this video, you will be able to write the empirical formula of a certain organic compound. In order to know how to write the empirical formula of a certain organic compound, let's solve this application together. Glucose is an organic compound, consists of carbon, hydrogen, and oxygen only. Given for you the percentage by mass of carbon, hydrogen, and oxygen respectively, and you have the molar masses in gram per mole for carbon 12, for hydrogen 1, and for oxygen 16. Determine the empirical formula of glucose. First of all, let the empirical formula of glucose be CaHbOC. So in order to deduce the empirical formula of glucose, you have to calculate A, B, and C. In a 100 gram sample of this compound, we can say that the percentage by mass of each element in this compound is equal to the mass of this element in a sample of 100 gram. So for carbon, the percentage by mass for carbon is equal to 40%, so we can say that the mass of carbon in 100 gram sample of this compound is equal to 40 gram. The same for hydrogen. The percentage by mass for hydrogen is equal to 6.714%, so we can say that the mass of hydrogen in a 100 gram of this compound is equal to 6.714 gram. Since the percentage by mass for oxygen is equal to 53.285%, so we can say that the mass of oxygen in a 100 gram sample of this compound is equal to 53.285 gram. So you can say that in 100 gram sample of this compound, the percentage by mass of each element is equal to the partial mass of this element found in a 100 gram sample. Now, you have to calculate the number of mole for carbon, for hydrogen, and for oxygen. In order to calculate the number of mole for carbon, it's equal to the mass of carbon divided by its molar mass. So here you can say that the mass of carbon is equal to the percentage by mass of carbon, which is equal here to 40%, divided by the molar mass of carbon, which is given for you, which is equal to 12 gram per mole. So till now, we found that the number of mole for carbon here is equal to 3.333 mole. Now we will move to calculate the number of mole for oxygen. The number of mole for oxygen is equal to the mass of oxygen divided by its molar mass, so it's equal to the percentage by mass for oxygen divided by its molar mass. So we can say now that also it's equal to 3.333 mole. Now for hydrogen, the number of mole for hydrogen is equal to the mass of hydrogen divided by its molar mass, and it's equal to the percentage by mass for hydrogen, which is equal to 6.714, divided by its molar mass, which is 1. So we can say that the number of mole for hydrogen is equal to 6.714 mole. Now you have to look at these three answers for the number of mole for carbon, oxygen, and hydrogen, and you will choose the lowest possible answer. So here the lowest value is 3.333. Now moving to the empirical formula, we say that the empirical formula is CaHbOC. So now we will calculate small letter A, B, and C. In order to calculate A, the lower subscript for carbon atoms, it's equal to the number of mole for carbon divided by the lowest value. So it's equal to 1 So here we will divide by the lowest value, which is 3.333. For B, which is the lower subscript for hydrogen atoms, it's equal to the number of hydrogen divided by this lowest value, and it's found to be equal to 2. Now, for C, it's equal to the number of mole for oxygen divided by the lowest value again, and it's equal to 1. So here we can deduce that the empirical formula of glucose is CH2O. So here we have 1 carbon atom, 2 hydrogen atoms, and we have 1 oxygen atom. Now deduce the molecular formula of glucose if its molar mass is equal to 180 gram per mole. Let the molecular formula of glucose be CXHYOZ. And you have now the empirical formula of glucose, which is CH2O. We can say that the molecular formula is equal to the empirical formula multiplied by a certain integer number denoted by small letter n. So n may be 1, 2, 3, 4, etc. So it must be an integer number. Now we can say that the molar mass for the molecular formula CXHYOZ, it's equal to the molar mass of the empirical formula multiplied by n. So you have just to substitute the symbol for the molecular formula and the empirical formula, and we will reach the following. We can say that the small integer number here, small letter n, it's equal to the molar mass of the molecular formula divided by the molar mass of the empirical formula. The molar mass of the molecular formula CXHYOZ is given for you, and it's equal to 180 gram per mole. But the molar mass for the empirical formula is missing, and you can calculate it. So we can say here that the molar mass of the empirical formula is equal to 30 gram per mole. Just you have to substitute the values, and we can say now that small letter n is equal to 180 gram per mole divided by 30 gram per mole, and it's found to be equal to 6. So we can say now that for n equal 6, the molecular formula is equal to the empirical formula multiplied by 6. So now, in order to deduce the molecular formula, you have to calculate x, y, and z. So for x, it's equal to 6 times 1. So here in the molecular formula, we have 6 carbon atoms. In order to deduce y, it's equal to 6 times 2, and it's equal to 12 hydrogen atoms. And for z, it's equal to 6 times 1, so we have 6 oxygen atoms in the molecular formula. So the molecular formula of glucose is C6H12O6. So the empirical formula simply states the ratios of the elements that make up the molecule, while molecular formulas specify the number of atoms for each element exactly, not just giving the ratio. So here we have the molecular formula of glucose is C6H12O6, while the empirical formula of glucose is CH2O. Thanks for watching.